Everyone, last time we did the balance labs, trying to balance the masses on a ruler and figure out that the reason that objects will stay in static equilibrium is because they have balanced forces on them, meaning that all the forces cancel out in all directions, there's no linear acceleration, and all the torques need to cancel in both directions. So that means that there's no angular acceleration equal. This is static equilibrium, so things need to not move or rotate whatsoever. So the two challenges you have down here are challenge 1 and challenge 2. In challenge 1, you must predict what each force sensor is going to read, but also with that F1 on the left side, you need to know the exact direction that F1 is going to pull. Is it going to pull up or should it actually pull down? And that all depends on how you set up your sum of forces and sum of torques. In this setup, let me kind of draw and explain some predictions that I might put on this to set this up. Also remember that for the bar that you're going to use one of the long bars that are in the classroom. Make sure you know the actual weight of that bar in kilograms, and make sure that you know the location of the center of mass, because that's where you're going to put F2. Force sensor 2, tie a string and hang that from the middle of the bar. For F1 though, let's see if we can kind of predict what direction that's going to go in. So I just drew the force of gravity vector at the far end of that beam, and now I want to think where force 2 is acting. Well, force 2 is acting right at that center of mass, so force sensor 2 is going to have a force vector straight up at the center of mass. So right now I've got a down force and an up force. But if I pick the pivot point to be right there, that means that the force of gravity on this side over here is going to cause a torque in that direction, and that force sensor 2 is actually going to cause no torque whatsoever because it's actually at the pivot point. So if that's the case, I need force sensor 1 to cause a torque in the anti-clockwise direction. And if you look at that force sensor 1 must be pulling down instead of up. So that's one hint that you want to focus on there. Predict what the force sensors will read based on having that 550 gram mass off the end. Predict them on the paper here and then test them out with the actual vernier force sensors. For challenge number 2 down there, it's more like a bridge. So rather than having the force sensors, you kind of have a scale. And you have two weights on it. You have a 300 gram mass and a 550 gram mass. At those locations, again, you can pick the actual distances, but it looks like, again, the 300 gram mass is right in the center, while the 550 is off to the right a little bit. Again, it can be unique for each of your groups. With this, you can put the force sensors sitting right underneath each of those ends of the beam to act like the bridge pillars, knowing that the 300 gram weight is going to pull straight down, 550 gram weight is pulling straight down, which means I know that both force sensors must be pushing up. So on challenge number 2 there, I can see that my forces are going to cancel out like that, and just like the problem up above, you have to worry about the weight of the beam as well. So remember, and I didn't add it on the first challenge here, but you will have to worry about it on the second challenge. You do need to worry about the weight of the bar. That's the blue arrow that I put there, acting at the center of gravity of our system. So good luck on these challenges and have some fun.